In this video, we are going to be learning about the attributes or characteristics of an absolute value function. Absolute value functions, by definitions, is the distance between a number and zero on a number line. And it is very much used in real life situations. The most important thing about absolute value that we need to learn is just the fact that absolute value is always going to be positive because distance is a real thing and it is measured in positive terms. So those are one of the importance stuff we need to take in. It is used in many areas of real life situations: distance, displacement, financial gain and loss, temperature differences, metrics, etc. And it's very, very, very important in our understanding of distance and depth, especially when you're looking at situations like sea level, above sea level, and below sea level type situation. The distance is still going to be positive regardless of what the situation might be. So, a scenario is temperature differences. Imagine the weather forecast says it will be 5 degrees Fahrenheit during the day and negative 10 degrees Fahrenheit at night. The question is, what is the difference in temperature between the daytime and nighttime temperatures? In this kind of scenario, this is, of course, an absolute value question. And absolute value gives us the total difference without considering whether the values are positive or negative. In this case, it helps us understand how far apart the two temperatures are, regardless of whether one is below zero or not. So we are looking at the attributes, just like any other function, it was going to have x values, which is the domain, and possible y values, which is the range. So in this graph, this is showing the parent function, which is the basic function of all, and the domain is all real numbers. Range is y is greater or equal to zero. X-intercept occurs at zero. Y-intercept at zero. Axis of symmetry at zero. Vertex is 0, 0, and the minimum y value is also 0. So it's very, very important to be clear at this point. We also do have axis of symmetry, and that will be the line that divides the absolute value function into two equal halves. And we also have the vertex. So the vertex sometimes can be named as the turning point of a function. And it's important to note that. Understanding the general form of an absolute value function is very, very important. The general form is given by y is equals to ax minus h plus k, where a affects the steepness and direction of the graph, and hk is the vertex of the absolute value function. H is the x coordinate, and then k will be the y coordinate. So it's very, very important to be able to know and identify it when seen in an equation. So the vertex is located at hk, where h is the value that makes the expression inside the absolute value function value 0, and k is the vertical shift of the function. For example, for the equation y is equal to 2 absolute value x minus 3 plus 4, the it will occur at 3, 4. On a graph, the absolute value function forms a V shape, and the vertex is at the point where the graph changes direction. That's very, so you have the minimum when it's pointing down or a maximum when it's pointing up. It's that important. So open upwards